Alright, let's look at a problem. A motorboat whose speed is 20 kilometers per hour in still water takes 1 hour more to go 48 kilometer upstream than to return downstream to the same spot. Find the speed of the stream. Alright, so in these motorboat problems, we need to know two things. One is speed of boat in still water. Let's say that is x kilometers per hour. The second parameter which is pertinent is the speed of the stream itself. Let us say this is y kilometers per hour. Now, when the boat is traveling upstream, then the speed of the boat becomes x minus y kilometers per hour. And when the boat travels downstream, understandably the speed will increase. So we write x plus y kilometers per hour. So keeping these in mind, let us look at the question. So the question tells us that motorboat whose speed is 20 kilometers in still water. So we know speed of boat in still water, which we have taken as x, is 20 kilometers per hour. And finally, they're asking us the speed of the stream. So that is the unknown. So we say let the speed of stream be y kilometers per hour. Now, if you look at the trip that is being undertaken, we see that there is an upstream trip which is 48 kilometers, and return to the same spot means the downstream journey is also 48 kilometers. So I'm going to divide this trip into two parts. One is the upstream journey. Let's call it the upstream trip, and this is the downstream trip. So the first parameter is the distance. The distance is 48 kilometers in both cases. The speeds are different. The upstream, if you see, there is a x minus y case, or the difference of the speeds case. So in this case, we need to write boat is 20 minus y kilometers per hour, whereas the downstream speed we will take as 20 plus y kilometers per hour. Now the time taken for the upstream trip is basically the distance traveled divided by the speed, which means time taken is 48 divided by 20 minus y, and this is in hours, and this would become 48 by 20 plus y hours. Now if you analyze these two, obviously the time taken for the downstream trip will be less because the speed is more. Therefore, this number is a smaller number and this is a bigger number. Another way of looking at it is, if you look at the denominator, if the denominator is smaller, the value will be a larger one. So therefore, this time is a larger number compared to this time, and the difference is given as 1 hour. So if we frame our equation as 48 divided by 20 minus y minus 48 divided by 20 plus y, all of this is equal to 1. So if we take 48 common, we get the LCM becomes 20 square minus y square, and this becomes 20 plus y minus 20 plus y. All of this is equal to 1. So the 20s get cancelled, and then we get this is 2y times 48 is 96y is equal to this denominator cross multiplies to the other side, becomes 400 minus y square. So the quadratic is y square plus 96y minus 400 is equal to 0. So we will try to split the middle term here. If you look at the product, it is 400, which we can write as 40 times 10, and this is again 4 times 10. So this is basically 100 and 4, which will give us a difference of 96, and then the product will be 400. So this we could write as y square plus 100y minus 4y minus 400 is equal to 0. If we take y common, y plus 100 minus 4 times y plus 100 is equal to 0. So the factors are y minus 4 into y plus 100 is equal to 0, which essentially means either y is 4 or negative 100. But we know what is y. Y is speed. Speed cannot be negative. Speed cannot be negative. Therefore, we say y is equal to 4. So final answer here is, and what is y in our discussion? Y is the speed of the stream, which is the question itself. So we report the answer as speed of stream is equal to 4 kilometers per hour.